Hello, Chiban Acharya again. In this video, I'll do the section 9.2 homework, estimating a population mean. So last section in 9.1, we did estimating population proportion. Here we do estimating population mean. I just want to let you know that the population mean has a symbol as a mu. That's the population mean. We want to estimate this population mean because we don't know what's the mean gonna be. Is here mean is called unknown parameter, unknown parameter, and we estimate that unknown parameter with the help of sample mean. Notice that sample mean is x bar as a symbol, x bar. We call this x bar, read it x bar as sample mean. Okay, we'll see that symbols later in this section. Okay, first question is question number 1. Use technology to estimate the following. Part A and B. In these two questions, part A and B, you got to find the critical value of t. Okay, so critical value of t for different confidence interval. I should say different confidence level. 99% confidence level with DF. DF stands for degree of freedom, which is one less than sample size. So let's talk about the first question, and I'll do the second one. Part A, you got to find the critical value of T for 99% CL. So CL for confidence level, here is a confidence interval, that's the same as same confidence level. CL equals to 0.99 in part A with the degree of freedom DF equals to 4. Okay, and you got to find the critical value of T. So critical value of T is denoted by T alpha over 2 as a subscript. Again, T subscript alpha over 2. This is together. It's not the multiplication. T alpha over 2. This is the critical value of T. Again, this symbols represent alpha. We did this in last section. That's the critical value. So in this question, we got to find T alpha over 2. So there is a different way to find the critical value. One way we can use a table. I'm going to show you in a minute. It's called T distribution table. Other way, we can find the critical value using technology. Here technology is TI calculator. So to find the critical value of T for given confidence level, first we need to draw the graph like we did draw in last section 9.1. So this is the graph here. This is called T distribution, not the G distribution. I'm going to put the T here, and that's the graph looks like, and this is going to be 0. Okay, so a 99% confidence interval, in other words 99% CL, that means this area here is 0.99. okay, 0.99. this is the middle area is 0.99. Every time you find the critical value for given confidence level, you got to see that confidence level as an area. This is the area. So how much left? Total area is under the curve is 1.99 is covered by this. So you have total area on the each side. This is called left tail and right tail. So total area is going to be called alpha. So alpha equals to 1 minus CL. So 1 minus 0.99, which gives you 0.01. That's the alpha. So each side, let me color that, this area here and this area here is going to be half of alpha. So this equals to 0.01 divided by 2. This equals to 0.01 divided by 2. So this gives you 0.005. This gives you 0.005. This is the first step you have to do to find the confidence interval. Doesn't matter, use a technology or table. I'm going to show you in a minute. It's the same thing. First you got to find. So area on the each tail gonna be 0.005. Total area on each tail gonna be 1, and the middle area gonna be 0.99. So this value here is critical value. This is called critical value. We call CV, okay? We call CV as a critical value. CV as a critical value in the short form. Or you can call alpha over 2 t alpha over 2 is this value. So I'm looking for this value. So I should say calculator function to find a critical value is going to be this t alpha over 2. You can use int t, that's the function. I'm going to show you how. And CL plus alpha over 2 comma degree of freedom, that's the function. So this is what you use in the calculator. This is the left area from this point here. This point is critical value. The left area from this critical value going to be, this is the CL plus alpha over 2. Notice that this is the left area. This is the left area. So you use that int function in the calculator to find the critical value. Let's do that. So in this calculator, like mine, you have to do a second VARS. That gives you this option, and int is number 4. Click number 4. See, and you have to type CL plus alpha over 2 together is 0.99 plus alpha equals to 0.01 divided by 2. Okay, again watch this here. Alpha is 0.01 divided by 2 because that's the function. You got to put CL plus alpha over 2 comma, and degree of freedom going to be 4. That's what it says here. First question 4 and close parenthesis, and that's the critical value of t. So enter, you get 4.60. okay, rounded to 2 decimal places. That's the instruction says here, round to 2 decimal places, 4.60. okay, that's the critical value. Now I'm going to show you how to find the critical value using a table. Some of you might not have this empty function in your calculator if this TI-83 old version. So if you don't have it, you use this table. Okay, this table this table is provided for you on the test, so you should be fine. So to find the critical value, you got to use this area, because look at the graph here. This is the critical value. You need the area on the right tail, this area. And if you look at this area, how much is that going to be? If you figure out this area on the right tail, and you can find the critical value easily. So let's see, in this question, the area on the right tail is 0.005. So what do you need to do? You look for 0.005. Where is that? Here, 0.005 here. Okay, 0.005. So look at the degree of freedom. What's the degree of freedom? Is 4. Okay, so what is 4? 4 is here. So you go this way, and 0.05, they meet in this point here. So this value here is critical value. So to find the critical value using table, it's pretty easy. You need to look for this right area, or area on the right tail, and the degree of freedom, and you look at the row of degree of freedom and column of degree of the area where they met. That's the critical value. And you see 4.60. 4 in 3 decimal. If you look at 2 decimal, it's going to be 4.60. That's how you find the critical value using table. That is real quick. Okay, let's do part B. It's similar to part A, but still I'm going to do one more questions. Critical value for T for 95% confidence interval. So here part B, confidence level going to be 0.95, and degree of freedom DF going to be 106. Okay, again, df stands for degree of freedom, and you need to find the critical value of t. That means t alpha over 2. And what you need is this. For this one, you use int t parenthesis cl plus alpha over 2 comma degree of freedom. So let's find the alpha and cl and put in this function. So again, it's better to draw the graph first. This is what the graph looks like. This is the t here, and that's the 0. And notice that this middle area is going to be 95%. Okay, so how much left? This side here is the left area, but I need the right area to find the critical value using the table. So let's find how much this area is going to be. So total area going to be 1, and this is 0.95 in the middle, so remaining going to be 0.05, which is alpha. So alpha equals to 1 minus CL is 1 minus 0.95 is going to be 0.05. So this area is going to be half of that. So 0.05 divided by 2 going to give you 0.025. Okay, this area is going to be 0.025. This area is going to be 0.025. So I need this area on the right tail compared with this graph to find the t score or t critical value of t from the table. But in the calculator you use this one, int function. Int CL gonna be 0.95 is here, and plus alpha gonna be 0.05 divided by 2 comma degree of freedom is 106. Notice that this whole thing you got to type under area, or depends on the calculator. This is called left area. This is called left area. Okay, but if you use a calculator, this is going to be looks like this. So here's second BRS, and number 4 is int. You type CL by 0.95 plus alpha is 0.05 divided by 2 comma degree of freedom is 106, close parenthesis, and enter. That you get critical value 4T of 95% confidence level, which gives you 1.98 as a 2 decimal. So answer is 1.98. Okay, this is using the calculator. Now using the table, how do you find it? You need 2 things to find the critical value of t using table. What you need: the right area or area on the right tail, and the degree of freedom. So you look for 0.025, which is gonna be where is that? Which is gonna be here, 0.025 here, and you look for degree of freedom. Degree of freedom gonna be 106. So notice that the 106 is not here, but you got to find the close degree of freedom to 106. So 100 is close degree of freedom to 106. So use this 100. So you go this way, and you see this way here, that number here. Let me circle that here. This number here. This number here is degree of freedom 1.984. So that's what we get to 2 decimal 1.98, and depends on the instruction. It says 2 decimal, so you use 1.98, but the table gives you up to 3 decimal 1.984, but if you round it, it's going to be 1.98. That's how you find the critical value using table and the calculator. Okay, next question number 2. Determine the t value in each of the cases. So here, this is the table we're going to use to find the t value. Still, you can use a calculator, but I'm going to use a table that is quicker. So to find the t value, you need the right area or area on the right tail and the degree of freedom. That's all you need. Notice that in the table, this row is right area or area on the right tail, and this column is degree of freedom. As long as you have a right area and the degree of freedom, you can find the t value. So in this case, what's the right area here? Right area is 0.005. That's the right area. Here is the right area, and the degree of freedom is 28. So you basically look for 28 and 0.005. Watch. So 28 here and 0.005 is here. So if you see those 28 row and 0.005 column, they met at this point 2.763. So critical value t value here is called 2.763. okay, let me say again, 2.763 again, where 28 row and 0.005 column met. That's the t value. 763. Okay, now next question, find the t value such that area on the right tail is 0.25. This is a area on the right tail or right area, and 9 degree of freedom. You're basically looking for 0.25 and 9. So 0.25 here and 9 is here. So they met at this point. So 9.25 met here. So 7.703. 0.703. That's the t value. So that's very easy to find the t value using table. So let's find the t value such that the area on the left of t value is 0.05. So they gave you left area. Okay, so let's say this is the area is right. What's your t value going to be? Think about 4c. What if 0.05 is right area? What do you think? What's the t value? Can you find it? Yes, let's do that. 0.05 with 29 degree of freedom. Let's find it. 0.05 is here. 29 degree of freedom is here. Okay, so 29 here. 0.05 is here. See, this is the value. Okay, watch here. 0.05, 29. So if 0.05 is the right area, t value going to be 1.699. Okay, but since this area is left area is given, the t value going to be negative 1.699 by the symmetric. So the idea here is you just find the t value using the right area. If even left area is given, you can think this left area as a right area and find the t value, and your answer has to be negative if left area is given. So if left area is given, your t value is supposed to be negative. So part D, find the critical t value for 95% confidence with 11 degree of freedom. So 95% confidence, what's the right area going to be? We did that before. For 95% confidence, you need the right area to find the critical value for t. So let me draw that picture. This is the that's what it looks like. Remember that this is 95% confidence. So it's going to be 0.95, and this is going to be 0.025. okay, 0.025, because total going to be 5% of 0.05, and you divide by 2, you get 0.025. That's the right area. You need to use this right area and 11 degree of freedom to find the critical value of t. So again, I see 11 degree freedom, and 0.25 is this one. So here the 0.25. So this value here is critical value of t, 2.201. 2.201. Okay, that's the question number 2. Question number 3, fill in the blank. D is the best point estimate for the population mean. That means sample mean is the point estimate. Okay, sample mean is the point estimate for the population mean. Again, sample mean symbols is X bar, which is called point estimate for population mean. Number 4, determine whether the following statement is true or false. To construct the confidence interval about the mean, the population from which the sample is drawn must be approximately normal. Okay, this is not always true. This should be false. Not always must be approximately normal. Yes, population either has to be normal or sample size must be greater than or equals to 30. Either or. So it doesn't have to be normal every time. The population does not need to be normal. If not normal, the sample size should be more than or equal to 30. So this tells you to construct the interval about the mean, the population must be normal. That's not the case. It could be normal. If not normal, still you can construct as long as sample size is bigger than 30. That's question number 4. Question number 5. A trade magazine routinely checked drive-through service time for fast food restaurant, 95% confidence interval that results in examining 518 customer in one fast food chain. Drive-through has a lower bound of 172.7 seconds and the upper bound of 176.1 seconds. So it looks like this. So 95% confidence interval looks like 176.1. Upper bound going to be 172.7. That's the lower bound, and upper bound is going to be 176.1. So this is confidence interval for population mean. This is the X bar. So what do you mean by this? That means, okay, that means one can 95% confidence that the mean drive-through service time of the fast food chain is between 172.7 seconds and 176.1 seconds. That's the right answer. That's the right answer. The first one is not the right answer because it's 95% probability. This is not the probability. This is the 95% confidence. So if you read C and D, doesn't make sense either. So this is the correct interpretation of the confidence interval for population mean. Okay, so question number 6, which of the following is not the equivalent expression of the confidence interval? As whatever given is here, that's the interval is given. So this first number here is lower bound, the second number is upper bound. So what's the margin of error and point estimate? X bar equals to 1's upper bound plus lower bound divided by 2. Let's find the point estimate. 189.5 plus 161.7 divided by 2. So if you do that, you get 175.6. 175.6. That's going to be point estimate. So this is the point estimate. What's the margin of error? Margin of error going to be upper bound minus lower bound divided by 2. Again, you refer the formula in the notes or PowerPoints. 189.5 minus 161.7 divided by 2, and that gives you 13.9. Okay, so you have upper bound, lower bound. So margin of error going to be 13.9. So yeah, the interval this way. Okay, lower bound comma upper bound, that's the interval. Another interval could be x bar plus minus e, that's the other interval. There's three different interval. Okay, other interval going to be x bar minus e less than mu x bar plus e. So you have three different form of the interval. So the first one is lower bound comma upper bound as a parenthesis. So 161.7 comma 189.5, which is going to be C is the right answer. Obviously C is the right answer, right choice. So D is also right choice, because this is x bar minus e mu x bar plus e. This is also right choice. And the first one is x bar, it's not the x bar, so that's not the right choice here, because the second number is not the margin of error. So e gonna be 13.9 plus minus x bar gonna be 175.6 here, you can hear. So this is the right choice. So answer is, which is not equivalent. So A is not equivalent. Every other are the same interval but different format. Only A is not equivalent to others interval. So you can see that confidence interval, three different form. Okay, so that's the question number 6. Question number 7. So refer to the accompanying data displaying the results from the sample output data speed in Mbps. Complete part A through C. So look at the interval here. That is already given for you. And this is lower bound, this is the upper bound. So if you write in the form, you in this first box, you put the lower bound, which is 13 point, rounded to 2 decimal, by the way. So you got to do 13.05 as a lower bound. Upper bound going to be 22.15. Okay, that's the interval. And this is also interval, by the way. This is also interval, one of the format. Upper bound comma lower bound in parenthesis format. This is the inequality format. 13.05 less than mu less than 22.15 format. So point estimate here is the best point estimate. So we're looking for x bar equals to upper bound plus lower bound divided by 2. That's the formula. So 13 point, you can do lower bound first. 13.05 plus 12.15 divided by 2. And if you add and divide by 2, you get 17.6. That's the point estimate for mu. Next question is find the margin of error. E gonna be upper bound minus lower bound divided by 2. So upper bound gonna be 12.15 minus 13.05 divided by 2, and you subtract and divide, you get 4.55. That's the margin of error. So part B is done. Part C, in constructing the confidence interval estimate of mu, why it is not necessary to confirm that the sample data appears be from the population with normal distribution. Pretty much the question is asking why the population do not have to be normal in this case, because look at the sample size. Sample size is what, greater than 30. As long as sample size greater than 30, we are good. We can construct the interval for population mean. So answer is because the sample size is greater than 30, actually sample size is 50, it is not necessary to confirm that the sample data appears to be from the population with normal distribution. Okay, that's the part C. Part D, determine the point estimate and the margin of error of the confidence interval. So I'm not going to do that since lower bound is 19, upper bound is 27. Point estimate x bar is upper bound plus lower bound divided by 2. Use the formula. Margin of error going to be upper bound minus lower bound divided by 2. Use the formula to answer the question number 8, because we did bunch of the question before, so I'm not going to do that. Question number 9 is similar to previous questions. Let me give you a hint. The trade magazine QSR routinely check the drive-through service time for fast food restaurants. A 95% confidence interval. The results are examining 637 customers. That is a sample size. In Taco Bell, drive-through has lower bound of 166.4. That's the lower bound, and upper bound of 169.4. This is the upper bound. So the question is asking for what's the mean service time for 637 customer. So basically, mean service time for 637 customers means find sample mean. So part A, you got to find X bar. So X bar formula is already have here, upper bound plus lower bound divided by 2. Use this formula. Second part, what's the margin of error for the confidence interval? So margin of error E, how do you find it? Again, since you have upper bound and lower bound, the margin of error is going to be upper bound minus lower bound divided by 2. That's the part B. Part C, interpret the confidence interval. So interpretation is, you got to fill the couple of blank here. So these two are not the right choice here. You can see that one can damage confidence. That mean drive-through service time Taco Bell is seconds. It doesn't have an upper bound and lower bound. So obviously this is not right because it's the probability here. So must be part A is a correct answer. One can 95 is a 95% confidence level. So one can 95% confidence that the mean drive-through service time of Taco Bell is between lower bound, which is 166.4, and upper bound of 169.4 seconds. That's the answer for part C, which is interpretation of confidence interval. Okay, question number 10. The question number 10, we need to draw the confidence interval for mean or confidence interval about mean for different sample size with the different level of confidence. So for part A, we have to draw the confidence interval for confidence level is 96%, 0.96, and the sample size is going to be 225. So what's the confidence interval in this case? That's the first question. Let me write down this way. For A, let's draw confidence interval for A, where X bar is 113, because it tells you the sample mean is found to be 113, and the sample standard deviation S is found to be 10. So S equals to 10. So first part A, N equals to 25, and confidence level equals to 0.96. So how do you find the confidence interval for population mean? You got to use the either calculator or manually. So I'm going to show you how do you find the interval using calculator. Now, so calculator function to find the confidence interval for population mean is this: start test number 8. That's the option. Start test number 8. That function in the calculator, you go to the start and the test, and you can press number 8, or you can scroll up or down. You find the number 8 if you like. Start test number 8. This is called T interval. That's the option. So there's two options here. There is a start data and start. Since I don't have a data here, I have a start, so I just need to select start option. Okay, and it's going to be highlighted. Press enter. So you see the start. You got to put the X bar, which is we have 113, and then this is sample standard deviation, which is 10. So sample size here is 25. That's the given here. And for part A, CL confidence level is 0.96. 0.96. So, and you just go to the calculate using this arrow button, and you just press enter. Then you get the interval, which is going to be 108.66, and say rounded to one decimal places. So the answer is going to be 108.7 and 117.3. That's the interval for the first question with 96% confidence level. Okay, let me type that. So first interval going to be 108.7 and the 117.3. So when you write it, you can write this way as well. Parenthesis 108.7 lower bound, comma 113.7.3 upper bound. That's the interval in part A. For the part B, you do the same thing for 96% confidence interval with a sample size 12. So here n equals to 12, but confidence level gonna be again 0.96. So I'm gonna use the same function, start test number 8, and find the interval. So you're gonna do start here, test number 8. You can type 8 directly. So, and you should have a start option because I have a x bar sample standard deviation. Mean x bar sample mean is 113. Standard deviation is 10 for sample, and the population's size here is 12. You reduce the population size 12 here, but the confidence level is 0.96. Same one for part B. So then you calculate, you get interval 106.28 and 119.72. If you round it to one decimal places, that gives you 106.9. Sorry, 106.3 and 119.7. So 106.3, 119.7. So it looks like the interval going to be 106.3, 119.7. So what happens here is, if you decrease the sample size and you keep the confidence level is the same, what happens to the interval? That's the next question. How does decreasing sample size affect the margin of error? But notice that this interval, the first interval with larger sample size is bigger than the smaller sample size. Notice that 108.7, 117.3. This 119 is upper bound, so this go further. Okay, so the second interval is, this is going to be wider, right? Because 106 is the lower bound, 190 is the upper bound, but this is 108 is the lower bound. So this interval must be narrower. So if narrower is smaller, then is bigger. So wider interval have margin of error larger than smaller interval. Okay, because margin of error going to be from here to here. Okay, just let me give you a sense here. This is the margin of error. So if this is larger, you have bigger interval, correct? So in this question, in this sense, this interval is smaller than this one, the second one, with 12 sample size. So we can say that as sample size decreases, the margin of error increases. Okay, you see here this bigger interval. So answer is going to be, as sample size decreases, margin of error increases. In other words, as sample size decreases, interval becomes larger. Okay, so um, uh, we finished A, B. Let's do the C. Part C, construct 90% confidence interval about mu if the sample size is 25. So for part C, what we're going to do is, again, we construct the interval with n equals to 25. The confidence level equals to 0.90. So let's construct that as we did before. You do start test number 8, and you have a start option, and then use the same mean, same standard deviation. The sample size is now you have 25, CL is 90. Okay, change the sample size 25, confidence level is 90.90. So, and then you calculate and you get the interval, which is 109.6, 116.4. okay, 109.6. let's find the interval here. 109.6 comma, that's the lower bound, 116.4. okay, 116.4. so now again, let's put the lower bound 109.6, 116.4. so now you compare this results to the part A. Let's compare this with the part A. Why? Because the part A, we use same sample size but different confidence level. What happens to the interval? Look at this interval. If you compare with the interval A with the C, this is narrower. So narrower because lower bound is 109.6, upper bound is 116.4, less than 117.3. so this is the narrower interval. So if interval narrower, margin of error is smaller. So as the level of confidence decreases, what happens to the interval? The interval also becomes smaller. That means margin of error is smaller. So here's the option. As the level of confidence decreases, 96 to 90, the size of the interval also decreases. Okay, that's the effect of confidence level into the margin of error. Part D. Could we have computed the confidence interval part A to C if the population had not been normally distributed? No, because look at here, all the sample size is less than 30, so we could not compute the interval if population is not normal. So the question tells you obviously the population is normally distributed, so we are okay to construct the interval if the sample size is less than 30. So the answer to this question is could we have been computed? No. Population needs to be normally distributed because sample size is less than 30 in all cases here. So answer is D. So question number 11 is same as question number 10. So you finish yourself. Similar, as soon as the same, similar to question number 10, you complete yourself. Okay, you complete yourself. As long as you understand question number 10, you are good with question number 11. Okay, this is exactly the similar. Question number 12. The accompanying data represent the total tax in dollar of 3 days business trip in 8 randomly selected cities. So here is the 8 data here. This is the total travel tax in dollar. So this is n equals to 8 here. And our normal probability plot suggests that the data could comes from the population that is normally distributed, and this tells you the population is normal. That tells you that's all we need. Determine the point estimate for the population mean travel tax. So point estimate here for this question is find x bar. That's the first question. Find the point estimate. X bar. Find x bar. What is x bar? At the sample mean. Sample mean. So how do you find sample mean for this sample data? So basically, to find the sample mean, you have to add all this data and divide by 8. That's the sample mean. That's the one way to do it. The another way to do the sample mean and confidence interval at the same time is using calculator. So we do construct interval and find point estimate x bar same time using calculator. Okay, you can do that. Let me show you how. So first you put the data in the calculator. Let me show you how to put the data. I think you know how to put data in the calculator from chapter 3. So you go to the start start edit is number 1. So put the data in L1. So if some data there, you remove it, put the data L1. So let me put that 68.48. Enter. I pause it and I finish the data. I'll come back. Okay. So I put the data in the calculator. Now I'm gonna do this. I'm gonna use start test number 8, the same one, to find the confidence interval for population mean. So I'm going to start test number 8, but since I have a data, not the start option, in this particular question, if you have a data, you choose the data option by scrolling this left arrow, right left arrow. So now data is highlighted, you enter, so you have a data. And my assumption is everybody has a data in L1, and there is L1 here by default. You choose frequency list as a 1, a confidence level as a given, whatever given here is 95. So I'm going to put 0.95 as a confidence level, 0.95, and calculate. So if you do that and you see that in that window, you can see this x bar, which is a point estimate. This is same as sample mean, which is x bar, 85.58 because of 2 decimal places. Sorry, 83.58. That's the sample mean. So even you have an interval here, and that's sample mean. Let me write down interval and sample mean somewhere here. Okay, at sample mean we get 83.58. 83.58. The interval going to be 73.83 comma 93.33. That's the interval. Okay, that's the interval. Again, let's check that. 73.83, 93.33, 2 decimal. So that's the interval. So to interpret, we construct and interpret. We construct interval here. We construct. That's the construction. Interpret. We do the same time on this question part B. So again, you check the answer. This provided not correct. This is also not correct. This is also not correct. So A is the right choice here. One can 95% confidence that the mean travel tax for all cities in between this lower bound 73.83 comma upper bound 93.33. That's the answer for part B. Part C. What would you recommend to a researcher who wants to increase the precision of the interval but does not access the additional data? If the researcher does not want to have additional data and want a precision of the interval, the researcher should decrease the level of confidence. Okay, that's the answer for Paul. C, B is the answer. Question number 13. Question number 13 is about finding sample size. So let me read the question. The doctor wants to estimate the mean HDL cholesterol of 20 to 29 years old female. How many subjects? See, that's the question. How many subjects are needed? That means what's the value of N? To estimate the HDL cholesterol within 3 points with 99% confidence, assuming S equals to 13.3 based on the earlier study. So here a couple of information you have. CL equals to 0.99, 99%. 3 points within the doctor want to estimate. That means 3 points must be margin of error. So E equals to 3. And the S equals to 13.3. That's the sample standard deviation. So the first question is, what is the sample size in this case? That means how many subject is needed if doctor wanna estimate with 99% confidence level and 3 points within with 13.3 sample standard deviation. So for this one, there is a formula for N. N equals to critical value times S over E square. Again, you refer the notes or PowerPoints for the formula for sample size when you estimate population mean. Okay, we have another formula for N that is to estimate population proportion, but we're estimating population mean, so this is the formula. So in this formula, this value here, Z alpha over 2 is critical value. So again, there is a given here partial critical value table with the given level of confidence. Excuse me, if there is not given value, you have to find it. We did it in 9.1. So how do you find the critical value? So for this case here, with the 99% confidence level, the critical value is going to be 2.575 here. So 2.575. This is the critical value. So I'm going to use that numbers there. So 2.575, okay, times 13.3 divided by margin of error, which is 3, and square of that. And if you do all in the calculator and round up to the nearest object, so say round UP up, that means always go higher integers. This gives you 131 subject. So if in this time the doctor needs 131 subject or 131 sample size. Now suppose the doctor want to estimate with 90% confidence. Now he wanna reduce the level of confidence from 99 to 90, and how much sample size required by the time. That's what we're gonna find. So here he did exactly similar the N formula, but sample size here to find it, you got to use the same thing, critical value times S divided by E square of that. But for the second time, he wanna estimate with the 90% confidence level. So for the 90% confidence level, the critical value is going to be 1.645. So I'm going to use 1.645 as critical value here. You see the critical value for 90%, 1.645 times 13.3 divided by 3 square of that. So if you do everything in the calculator and round up to the nearest integer, you're going to get 54. So with 99%, we need 131. With 90%, we need 54. So how does decrease in the confidence level affect the sample size? So if you decrease the confidence level, you need smaller sample size. So decreasing the confidence level decreases the sample size needed. That's the part C is the answer. Okay, you see that when you decrease the confidence level, the sample size required is decreases as well. Question number 14. You got to read very carefully. Suppose you have two populations, population A, that's the A here, and the population B here. Okay, so the population A is all students at University of Illinois. So N here is 21,000 in the all students in Illinois State University. This is university students, right? University student. And population B also has a size 21,000, the same size. And these are all residents of the Homer Glen, Illinois. So these are the residents of Illinois City, Homer Glen. Okay, all RESI residents of Homer Glen. Okay, GL Glen. So now you want to estimate the mean age of each population using two separate samples of each size 75. So you pick the sample 75 here, and you pick the 75 sample here, same sample size, from the population of same size, right? So if you construct 95% confidence interval for each population mean, if you construct the interval for each group of data, so again, notice that you construct interval per population mean age. Okay, we talk about the age here, age of this two group, mean age of the group. So obviously university students are less dispersed since they are university students. Most of them are, let's say, 18 to 25 or 30 around. But the B, which has all residents of the Homer city, are more dispersed. So this B has larger standard deviation than A. So this is less dispersed age, right? So this is going to be less standard deviation compared to population B. So if standard deviation is smaller standard deviation, smaller margin of error. Okay, margin of error. So if you construct the interval for both population, the interval for A going to be smaller than interval for B, because A has smaller variation of the age. That means A has smaller standard deviation compared to B. So the answer is going to be part D. The margin of error of population A is smaller because standard deviation of this population A is smaller. That's the answer. Okay, question number 15 is similar to other we did here. I'm just giving you a hint here. In the question 15, in the random sample of 81 audited tax return, so here n equals to 81 sample size, it was determined that the mean amount of additional tax owed was $3,465. This is sample mean, 3465 x bar, because this is the mean of those 81 audited tax return, and the standard deviation A is 2594. So this S equals to 2594. This is called sample standard deviation because this is the standard deviation of those 81 audited tax return. Construct and interpret 90% confidence interval for the mean additional amount of tax owed for the state tax return. So you have CL here 0.90. So using this information, use start test number 8 and select start option, start not data, because this is the start in the calculator, and input those data and calculate. You will find the interval and you will find the lower bound, upper bound in the calculator, and your answer is not this one because the probability. You choose this answer, you put here lower bound and you put here upper bound, thus you get from the calculator. Again, we did this before a couple of times, so you should be fine. Question number 16. Again, this is similar to others. Again, I'm going to give you a hint for that as well, so you finish yourself. So our data set include 103 body temperature of healthy adults, human having a mean of 98.9 Fahrenheit and a standard deviation of 0.67 degree Fahrenheit. So here sample size is 103 of adult healthy human body temperature. We take 103 people body temperature and we found the sample body temperature is going to be 98.9 degree Fahrenheit as a mean, and the sample standard deviation S equals to 0.67 degree Fahrenheit. Okay, now CL here equals to 99%, 0.99. So using this information in the calculator, you construct interval in the calculator, and you see this parenthesis on the calculator. This is the lower bound and this is the upper bound. So in this questions, you first box here, you put the lower bound from the calculator, and this second box you put the upper bound from the calculator. Okay, let me find this one particularly. So I'm going to do again start test number 8, right? Number 8. So I'm going to choose start option here, and since I have a start here, is X bar is 98.9, 98.9. The sample distance is 0.67. Okay, and the sample size is 103, and this confidence level is 0.99. So that's how I put the data, and you scroll down and calculate. So you get 98.727. I should say 98.3, rounded to 1, that's a 2 decimal, 98.73, 99.07. So that's the answer. Let me put down here. Lower bound we get is 98.73. Upper bound we get is 99.07. Let's check that again. 98.73, 99.07. So that's the upper bound, lower bound. So what does this suggest about 98.6 degree Fahrenheit as a mean body temperature? The mean body temperature 98.6 degree Fahrenheit is not inside the interval, confidence interval. So this suggests that the mean body temperature is higher than 98.6 degree Fahrenheit. That's the answer. Okay, that's the answer for the last part of this question, number 16. Okay, 17. Find the margin of error for 95% confidence interval for estimating population mean when the sample standard deviation equals to 100 and sample size first is 400, second is 1444. What does this affect the sample size? So you got to find the margin of error for 95% confidence interval with different sample size. Here you go, part 1 and part 2. Let's do different way. Part 1, CL equals to 0.95. Part 2 also CL equals to 0.95. Okay. Standard deviation equals to 100. Here standard deviation equals to also 100. But sample size here is 400. In this case, sample size here is 1444. So let's find margin of error here. What is the margin of error in this case? What's the margin of error in this case? You got to find margin of error in both cases, and you write the answer here. Okay, so to find the margin of error, there's a formula we're going to use for margin of error. Okay, so margin of error formula is what's the formula? Okay, here you go. This is the margin formula. E equals to critical value for t alpha over 2 times standard deviation over square root of n. So basically in this question I'm looking for critical value here, how much critical value here, and how much critical value here. So as long as I know the critical value in both cases, I can use the formula to find the margin of error, so I can put the answer. So what's the critical value in each cases? So again, critical value depends on the right area and the degree of freedom. So here, degree of freedom here, because of n is 400, degree of freedom equals to n minus 1. So 400 minus 1, 399. Notice that degree of freedom is 1 less than sample size. In this case, degree of freedom is going to be 399. In this case, degree of freedom is going to be 1439. Okay, that's the DF. So we have a degree of freedom for each cases. So let's find critical value of t for each. But in each cases, you got to find the how much area on the right. So that's what it looks like. So this is the 95. Remember that we did that before also. So this is the right area. How much is that? This is going to be 1 minus 0.95, which gives you 0.05. So remaining area is 0.05 in each side. In both tail, total area going to be 0.05. So area on the each side or each tail going to be 0.05 divided by 2 is going to be 0.025. So this is going to be 0.025. This also going to be 0.025. But I only need the right area and the degree of freedom. So we have a right area here, 0.025, and degree of freedom for this cases here is 399. Let's find the critical value of t. So here's the table. So I'm looking for degree of freedom 399, but remember that 399 is not here, but 399 is close to 100 rather than 1000. So I'm looking for 1000, the closest to 399, and I'm looking for right area is 0.025. So this is the 0.025 column. Scroll down here. So 399 close to 100, then 1000 is 1.984. So critical value here is 1.984. Okay, let me write down here 1.984. Similarly, for this case here, to find the critical value, again area on the tail is 0.025 on the right. This is the right area. So now degree of freedom is 1439. So let's find 1439 degree of freedom. We don't have that, but it's close to 1430. 1439 is close to 1000. So let's find the area 0.025, and this 1.962. So 1.962 is a critical value for t. So we have a critical value for each cases, remember that all are the same except this sample size and critical value, slightly different here, and you got to find the margin of error. So margin of error E equals to, the formula is, I have it here, the formula here. So I'm going to use critical value times S over the square root of N. The critical value is 1.84, 1.984 times S is 100 divided by square root of 400. So use a calculator. This equals to 9.92 as a 2 decimal places. And in other cases here, in this cases, E equals to again 1.962, that's the critical value. Again, we have the formula here, times S gonna be 100 divided by square root of N gonna be 1444. Okay, so if you simplify using calculator, you get 5.16 as a margin of error. And you see, this is the margin of error for sample size 400, and this is the margin of error for sample size 1444. So next question asks you, what is the effect of the sample size on the margin of error? So that's the question. So what you notice is, as you increase the sample size from 400 to 1444, the margin of error going to be decreases. So the answer going to be, as the larger sample size, margin of error is less. So the larger sample size decreases the margin of error. That's the answer. Okay, that's how you see that. See, the larger sample size decreases the margin of error. Last question, the sample mean, sample size and the sample standard deviation are obtained and given below. Find the confidence interval for the mean and the population from which the sample is drawn. First question is find the confidence interval, part A. Part B, find margin of error using upper bound lower bound formula. And last part is find the margin of error using the formula, this formula. So there is both B and C, find the margin of error different way. For part A, you gotta find the interval. So again, I'm not gonna find the interval. I'm gonna write just the interval, what I get in the calculator by myself. I pause the video and I find the interval and write the answer. Okay, I did find the interval using the test number 8. I used that and I found that interval gonna be this, 31.336 comma 36.664. Okay, rounded to 3 decimal places. That's my part A answer. Now this is the lower bound, this is the upper bound. So part B says find the margin of error by using the upper bound lower bound formula. So E equals to upper bound minus lower bound divided by 2. That's the formula. 36.664 minus 31.336 divided by 2. So if you subtract and divide, you get the margin of error is 2.664. So this is the answer for part B, 2.664. Now we have to use this formula for margin of error to see if B and C are the same answer. Okay, so for C, use the margin of error formula, T alpha over 2 critical value times S over the square root of N. So basically we got to find critical value here like we did before. Remember that how we find the critical value here in the previous question? That's what we do. So to find that, you got to find the right area on the tail. So for 95% confidence, Okay, for 95% confidence level, area on right tail is how much? Equals to 0.025. Again, this is the same one. Okay, here we did that. See, and the last question, for 95% confidence, we find the area of the east tail is 0.025. But degree of freedom is different. What's the degree of freedom in this case? Degree of freedom here is sample size -1 and -1, which is going to be 16 minus 1, because there is a 16 here as a sample size, 15. So I'm looking for critical value for t using 15 degree of freedom and 0.025 as area. So let's find it. 15.025. Let me table here. 15.025. 0.025 here, 15 here. So okay, this 2 column and the row meet here. So this is the value, 2.131. okay, 2.131. So critical value in this case here is, in this case, t alpha over 2 is 2.131. let me double check. Yeah, 2.131. Now I'm going to use that to find the E using the formula. So E going to be 2.131, which is critical value, times S. What is S here? S here is 5. I can see here. This is 5 over, so the 5 here, over square root of n. The sample size here is 16. Of course, we have it here 16. So I'm using this everything in the calculator, and we found it. Let me do that. So if I put this everything in the calculator, I get 2.6637, and then if I round it to 3 decimal places, it's going to be 2.664, which is same as we get from the upper bound, lower bound. Notice that from both cases you get the same margin of error. Either you use a formula or upper bound, lower bound, you get the same answer. Okay, that's quite long homework section. Thank you for watching with the patient. Good luck.